Hello, everybody. I'm Gerhard Lackner and very happy to welcome you to today's seminar about Polaris grinding disks. Today, Luvan will give you a PowerPoint presentation, and we try to support you in this challenging Corona time with that. And afterwards, we will send a download link because this webinar is going to be recorded. So all the information here will be available afterwards as well. And just a few hints on the schedule, how this webinar is planned. First, Luvan will give the presentation, and throughout the whole presentation, you can ask questions in a written form, and I will try to answer them directly. And right now, I would like to hand over to Luvan-san, who prepared this wonderful presentation for all of us.
Thank you, Gerhard, for the introduction, and to everybody else, hello and welcome to the webinar. Today we will talk about the Polaris grinding disks, and there are more webinars to come in the next weeks. We will also talk about the small precision cutting machine in the beginning of June, and some mounting consumables and so on. So our webinar today is about a new grinding consumable. After a short overview, I will talk about the Polaris grinding disks in more detail, about the composition, properties, and the application of the Polaris grinding disks. Afterwards, I will show you results of a case study and two preparation examples that we did in our ATM lab with the Polaris disks. And at the end, you will be given a short summary. So as you know, we as new QATM is formed of the former companies ATM located in Mammelsen, Germany, and QNIS located in Golling in Austria. Now acting together, forming one company, QATM. That means that our product portfolio has also merged together. And besides the machines for sectioning, mounting, grinding, and polishing, the hardness testers have been added. Then we have the consumables for all areas. We have lab furniture and software for analysis. Now we will be looking at the grinding disc, which belong to the grinding consumables. I think most of you already know about the new grinding discs, and many of you have already had an introduction or has been working with some of them. So now there is a broad variety of grinding discs available for a broad variety of different materials. And one of the big advantages that grinding discs have compared to, for example, grinding paper is the rigid steel carrier, which allows the production of very flat samples with a high edge sharpness. Additionally, no extra tools are needed to attach the grinding tool onto the working wheel. The high service life of the discs lead to a more environmentally friendly preparation method since less waste is produced compared to grinding paper. Today we will only talk about Polaris SiC, M, and H. These three discs have the same design but different properties. In principle, they differ in two things: abrasive and bonding. Polaris M and H work with diamond abrasives, so they are diamond grinding discs and usually are used for materials that are harder than 300, 400 Vickers hardness. The diamond grain sizes are typically given in microns, and you can find this number on the front side in the middle of the disc. The SiC grinding discs contain silicon carbide grains, and the grain sizes are given according to the FIPA standard, so in the same way as silicon carbide grinding paper. Here again, you can find the grid number on the front side. And the second thing that differs is the bond hardness. All three discs are resin bonded, but the hardness varies, which is realized by different hardening procedures. And this again influences the grinding behavior of the disc. On this slide, you can see the composition of a diamond disc in the cross-section. On the very bottom is the metal carrier, which is coated on the back, providing a rough surface. It looks like this, and the rough surface enhances the surface grip, preventing the disc from sliding sideways. A textile is glued onto the metal carrier. This textile is very similar to our batter cloth, and on this textile the grinding segments, which are composed of diamond grains embedded in a resin matrix, are printed onto. The diamond concentration in these grinding segments is very high, so we have a lot of abrasive grains that contribute to a high stock removal rate. The textile intermediate layer minimizes vibrations that arise during grinding and leads to an improvement in the surface quality. Another property is the narrow grain size distribution of the diamonds. Here, a special technology is used to achieve this narrow distribution. Because this always applies. The narrower the grain size distribution, the better. So if you have a broad distribution, you will have many oversized grains that will scratch your surface, and at the same time, however, you also have many too small grains that do not even take part in the grinding process. A narrow distribution means a high removal rate and good surface quality at the same time. So these are some important quality features that you should keep in mind. As a rule of thumb, you can say that Polaris M is suitable for grinding medium hard materials, typically for medium hard metals or composite materials. For hard materials, however, Polaris H with a hard bond is more suitable for like fully hardened steel or materials with hard layers, ceramics, glass, or composite materials with hard components. The grinding discs are available in different grain sizes from 60 microns or 125 microns as the most coarse grain size down to a fine grain size of 3 microns. If you, let's say, grind with 4,000 grit paper, which is usually the finest grit, then this corresponds to a grain size of approximately 5 microns. So we get even a bit below that with the 3 microns. The next step would usually be diamond polishing in a range from 15 microns down to 1 or 1/4 microns. So with grinding discs with grain sizes of 15 to 3 microns, we are already in the polishing area and can therefore replace polishing to a certain degree. Keep in mind that compared to polishing, grinding is always less effort. So yeah, that is an advantage, and also in the sense of saving time and lowering costs. Also, the environmental aspect should be mentioned here, because unlike polishing, you do not need any lubricant. The diamonds are used more efficiently and you produce less waste compared to grinding paper. Now let's look at the Polaris SiC discs. This one can be used for rather softer materials or materials that cannot or should not be grinded with diamonds. The grit sizes range from 120 to 1,200. The next slides will be about the application of the Polaris discs. In many cases, before applying a grinding disc for the first time, you have to dress it with a dressing stone, which is typically an aluminum oxide or silicon carbide stick. But this pre-dressing is not necessary for the Polaris discs. They can be directly applied, so you are saving a working step here. There are some things that I would like to point out. As for every consumable, the correct handling is very important to assure the quality and service life of the tool. These are the main points to be taken care of. So in the beginning, please always ask these questions. Do I have the right disc for my material? Are they embedded in resin or not? Is the water cooling sufficient? Have I chosen the correct parameters like force or rotation speed, and so on? In order to gain a more homogeneous wear, it's recommended to vary the rotation direction from time to time. Also clean the discs regularly, since a smeared disc will not work as sufficiently as a clean one. So if you have taken care of all that and you have good conditions and let's say an advantage material, we can roughly estimate a tool life compared to approximately 1,000 grinding papers for the diamond grinding discs. I will give you an example on that shortly after. And of approximately 1,000 grinding papers for Polaris silicon carbide. I would always recommend, if you have the possibility to mount your samples, please always do that. This way, the probability of damaging the discs by canting is minimized a lot. Then I mentioned that it's important to clean the discs regularly with a nylon brush, of course, but also with the cleaning stick in case of smearing. This cleaning stick is also made out of aluminum oxide with a relatively low hardness. This stone should be stored in water at least 10 minutes prior to use to have a good cleaning effect because it takes up a lot of water. An indicator that the surface of the disc is smeared is when it appears shiny metallic, which happens fast if your material is a ductile metal. Also, your polymer resin can smear the surface. And the next indicator is when your disc is not worn out but just doesn't seem to do its job anymore. The abrasion rate decreases a lot and you need a lot longer to finish your step. So if that happens, use the cleaning stick to remove the smeared layer so the abrasives are at the surface again and do their job. So let's see, next slide. So the cleaning procedure is a kind of dressing of the uppermost layer. You first have to turn on the water cooling and the working disc. Then take the cleaning stone, which you have kept in clean water in both hands, and bring one edge into contact with the rotating disc with a controlled even pressure. While cleaning, there will be a grinding noise. And be sure that you move the stone over the entire radius of the disc so that the disc is cleaned evenly and is conditioned. Do this as long as necessary. Normally, a minute should be enough. You will then notice wear of the cleaning stone, which is totally normal. And with one stone, you can do several cleaning operations, and you can, of course, reorder this cleaning stone if needed. After the process, you can rinse the stone and the disc and put the stone back in the water if you want. We here at ATM, we just store the water, the stone in the water the whole time. Here you can see microscopic images of the surface of a grinding segment. In the left picture, you can see a disc with large parts clogged. After cleaning with a nylon brush, there is no real improvement. Only after you have removed the stone, you will see that almost the entire surface is free again. So the stone must be used as soon as you notice that the disc is clogged and no longer working properly. Now I will talk about a case study that was conducted with the Polaris H, where HVOF layers were prepared under real conditions with Polaris H discs in the grain sizes 60 microns and 15 microns. They used full sample holders with 6 embedded samples, and the removal rate and the surface life was measured. It could be observed that the same disk removes about twice as much at a rotation speed that is twice as high, so the removal rate is more or less proportional to the rotation speed. Of course, the finer the grain size, the lower is the removal rate. According to the protocol, the 60 micron disk had a total operating time of 50 hours and was still fully operational afterwards. During the study, it was regularly cleaned with the cleaning stone. Here you see a picture of a grinding segment before and after the 50 hours operating time. You can see how the thickness of the segment has decreased significantly. So assuming a disk can operate for 50 hours, which is 3,000 minutes, and if you assume that a grinding paper is used for, let's say, 2 minutes, we would need 1,500 papers for the 50 hours. So in this case, the Polaris H disk with 60 micron diamond grains could replace more than 1,500 silicon carbide grinding papers. With this method, the results were very satisfactory and the layers didn't break out. Therefore, it is possible to develop alternative methods to conventional grinding paper preparations. And that is great because, as you know, we offer solutions for material preparation, which includes preparation instructions and guides in form of these booklets, or can be also found in our solution boxes. Well, so far the preparation methods are mostly preparations with a grinding paper, but we want to use the new possibilities that we have now to develop new preparation methods with the Polaris grinding discs. In order to do that, we have to test these new methods in our preparation lab. So one of the materials that I started with was case hardened steel using a piece of pinion shaft as sample mounted in EPO black. This is how the standard preparation looks like. The first step would be grinding with conventional grinding paper grit 320, then diamond polishing on beta with a 9 micron suspension for 5 minutes, and then on delta with a 3 micron suspension for 6 minutes. After that, we do final polishing with eposal on the omega cloth, and at the end, etching to visualize the microstructure of the sample. If you add the two diamond polishing steps together, the time that is needed only for diamond polishing is 11 minutes. And here we see a big potential to save some time by grinding instead of polishing. Now, based on this motivation, I created a new preparation method. This is what it looks like. I chose Polaris M as the grinding disc and did all the grinding steps with Polaris M. In principle, you could also switch between different discs if the material allows it. So you could start with Polaris H for the coarse grits and continue with the M disc for finer grits. But yeah, I've now done all the grinding steps with M, replacing the 9 micron diamond polishing step with a 15 micron grinding disc and the 3 micron diamond polishing step with the 3 micron Polaris M grinding disc. The grinding time was 3 minutes each, so it would be a total of 6 minutes preparation time instead of 11 minutes. I also replaced the 320 grit paper surface grinding step with Polaris M 30 microns. In this case, planar grinding took about 2 minutes. The additional advantage here is that you get very good flatness and edge sharpness due to the hard steel base. If you use foiled grinding paper and standard adhesive carrier, for example, then the surfaces are often rounded off because of the soft layer. And yeah, after that, after the 3 micron grinding step, I continued as usual with final polishing with eposal and omega. In summary, there are several advantages with the new preparation method. In addition to the good flatness, the preparation time is shorter. We need 7 minutes in total instead of 12 minutes, so the sample throughput can be increased within the same time, and less consumables are required by replacing the 2 diamond polishing steps with grinding steps. Also, replacing the paper produces less waste in the long run. It is also more cost effective. So now a few pictures. Here you see micrographs of the surface produced with the conventional method. In the first picture on the very left, after 9 micron polishing on the beta cloth. In the next picture, after 3 micron polishing on the delta cloth, and on the very right, after final polishing with eposal on the omega cloth. In comparison, you can see the micrograph on the left here after grinding on Polaris M with 15 microns. Of course, you will see a significantly coarser pattern as of 15 micron abrasives are used instead of 9 microns, and also we have bonded abrasive grains here, which also affects the grinding pattern. In the middle, we have the 3 micron step again, this time with the Polaris disc. And if you compare with the 3 micron diamond polishing in the previous slide, you can see that there is no really significant difference here. In the third picture on the right, you can see the result after fine polishing with Eposal for 1 minute, so the same as before. And directly compared, the results after final polishing are really just the same. I then etched the samples, and you can see the result here. In both cases, the microstructures are clearly visible, the martensitic structure in the outer area and the original structure in the inner area of the sample. So with the new method, we can achieve a very good preparation result and on top save 5 minutes of preparation time. Another material that we prepared was aluminum alloy. This is the conventional method, and in order to save time again, we replaced the pre-polishing step with the Polaris silicon carbide disc, grit 1200. Also, the planar grinding step was replaced by Polaris 500 to get a better flatness. The results show again, although in the second picture the brightness setting was maybe a little bit too high, but it shows that again the new preparation method with grinding discs is first of all replacing the grinding paper in a good way, and second of all replacing a polishing step, and it works for this material as well. Now we are slowly coming to the end of the webinar with a summary. You saw that it is possible to optimize preparations with the Polaris grinding discs. Of course, they are not a universal solution to all problems, but in many cases, they offer a great potential. The most important points that apply to both the diamond and silicon carbide discs are a high level of flatness and edge sharpness of the samples, which is achieved by the hard steel base. This steel base also enables the use on magnetic working wheels without additional tools, and the rough coating on the back of the discs enhance the grip, preventing the disc from sliding sideways. In addition, grinding discs are more environmentally friendly compared to the conventional methods with grinding paper. The Polaris M and H diamond discs are also available with very fine grains down to 3 microns, as you saw, which means that polishing steps can be replaced, and it can save time and money. And the high diamond concentration and narrow grain size distribution are quality features that lead to an increased removal rate and surface quality, and also to a long service life. The height of the grinding segments is 0.4 millimeters, and all discs are available in the diameters 200, 250, and 300 millimeters for the available grinding and polishing machines, and in 350 millimeters for the new Q-Pole XL will be released soon. Now that brings us to the end of the webinar. Thank you very much for joining the webinar. Thank you for your attention. If you have specific questions regarding the Polaris discs or some feedback, you can also contact me. My email address is shown here. Also, visit our new website if you haven't already, presenting QNIS and ATM together as QATM, where you can find the whole product range in materialography and hardness testing.
Well, one question was about the sample preparation methods, if we are going to update them. And yes, we are going to update them, and we will keep the standard preparation methods as is with the old consumables as well, and we will enhance this brochure with new preparation methods, including the new consumables. So this will be also supported by us. And another topic which was asked was the cleaning. If you do, or if the customer has to clean the new consumables every time when they're going to use it. So that's not the case, but every time you face a difference in the performance of these consumables, you need to clean them, and this is strongly dependent on the material you're going to prepare. And these are, I guess, all the most important questions. And one was if this Polaris can be applied for stainless steel, which can certainly do the job of preparing the surface of stainless steel. So I hope you learned a lot and had a lot of fun following us during this webinar. And as mentioned, we will send a download link with a record of this webinar. And thank you very, very much for sharing your time with us. And we wish you the very best and stay healthy.